Hello and welcome. I'm Hullhound and today we'll be continuing our Frogger clone using Godot. If you haven't already, I recommend starting from part 1. In our last video, we set up extending platforms, unstable platforms, and finalised the setup of our water hazards. What is the most important thing that our game is currently lacking? I would say it's probably the way to win. Currently, we don't have a way to actually finish the game and complete it. So what we're going to do next is we're going to add in a set of flags that on the last row that the player can go and collect, and then once they've collected all of the flags, they'll get a win screen and that'll be complete. Let's create a new node, which we'll call flag. Be a node 2D. We'll rename it flag. This node needs to have a sprite 2D, so we can visually see what we're looking at. I'll just quick load. I'll load our assets. So in this case, I just want a red flag. You can see here. Like everything else, let's set that to be not centered. And let's add a area 2D as well. So because we want the object to be pick upable, we need to give it some functionality for that. In this case, area 2D seemed like a good shout. For its collision, I want this to interact with the player, which is an area 2D itself, and I likely need a new collision layer. So let's go to project settings, go down until we get to 2D physics. Let's add in flag as a physics layer. We can then set this to be a flag. We don't need a mask because the flag itself won't be looking for anything at the moment. We'll make it look for the player shortly. Actually, I guess we can just do that now. Excellent. So we need to add a collision shape. So let's do that. And that's so the area 2D knows when something has actually interacted with it. So I'll allow sprites of 16 by 16. Do that, and then we give it an offset of 8 by 8 to center it. Okay, now let's just mark this as a new scene, call it flag, and move into the scene. Here we have our flag nice and straightforward. If we add a script to it, we can give it some custom functionality. Specifically what I'm interested in is having a signal called picked up. Nice and simple. If we connect to our area 2D, on the area entered signal, then we can now call picked up, since we know that the only thing that's going to collide with this area 2D is the player. When the player collides with the flag, the picked up signal should be run. We go to our level. I'm going to move the flag to be a bit lower so we can easily get to it without having to go through all of the hazards. So 1, 2, 3, 4, 5, 6. 10 times 6. And if we then press play, I'll get nothing because I've not set up any functionality. If we quickly change that, so if on our level script, which we don't actually have, let's fix that. Got level script, and on our flag, let's subscribe to that signal. And we can then say print. Print will write a message into our console or terminal. Flag picked up. Press F5. You can see that when we enter it, we get flag picked up. At this point, how about a quick exercise? something we've done a few times now, but let's take the flag and let's make it so that we can customize the image that's being used for the flag. In the asset pack from Kenny, we have a number of different flags with different colors. So what we need to do is create code so that the flag can have 5 different variations, or any variation, and then place them onto our level. So what I'm going to do is, I'll show you how I do it in a moment. I'll set that up, and then I'll add 5 flags to the top row, having them placed on platforms. Give that a go, and see you shortly. There are 2 ways that we can use to set the flag image to be variable. Simplest way is by adding an export variable to our object, so our flag object. We'll just call it texture, and we'll get a type of a texture 2D. And all we do is on ready, we say $sprite2d dot texture equals texture. And if we then go into our level, if you're interested, it's a Control P, gives you the quick open option. So here, all I need to do is take my flag, and I can change the image to, quick load isn't useful when you don't know what the name is, to let's say a orange flag. I then press F5, get an orange flag. The more complicated option, so that we can have the change actually be viewable in the editor, is we add the @tool directive, and then we change our system to be a setter and getter. So in this case, we can do set value, and then sprite2d dot texture equals the value. Add in a get as well. Return sprite2d dot texture. So the format for this is variable type colon, separate line, set, and then you provide the value so that you can know what value is being added, and then a colon, and then an indent, and then similar for the get, so get colon, and then an indent, and that has to return a value. If we go to our 2D level, we can now see that our flag is looking orange. If you haven't already, use this opportunity to set up your level as you want it to be in its final state. So as a reminder, I'll be adding in 5 non-moving platforms at the top, and then putting a flag on each of them. Give it a go. Welcome back. Hopefully that was a fairly straightforward exercise. So what I've done is I've added in 5 platforms at the top of the map that are just safe platforms that don't move. I've added in 5 flags on top of those that are using different sprites for their colours. I've duplicated the original flag that we had, so the signals are still hooked up, meaning that all 5 of these, when touched, will cause the flag picked up message to show up in our terminal. If you had an issue with that, please let me know in the comments, and I'll see what I can do to help you progress. Now that we have our flags in place and we have a win condition, how do we know how close we are to actually winning? On one hand, we do have the ability to actually just see everything that's on screen because it is a one-screen game, but let's make it a bit clearer. Let's add in a display at the bottom that highlights how many flags we've actually already collected. Let's do that now. To do this, we'll need to create a new image display node. So let's start by creating a node 2D, which we can call flag display, and then adding a new script onto it. Flag I'm going to call this image display, not flag display, as it's a generic node in its own right. So if we would say class name, image display, then we'll be able to use that later on if we so need to. So the flag display or image display node has a few things it needs to do. It needs to fundamentally track a value. So we could do this using a inner node, but that's not for the moment, just to keep things straightforward. And then it also needs to display an image with an offset for any given value that it has. So starting off in no particular order, let's start by adding an export variable for a texture. This is the actual image that we'll be displaying when we are trying to display a value. We also need a texture offset so that we can have multiple of them side by side at a set distance from each other. And that'll just be vector 2D, or vector 2, and I'll set it to have a default size of 16 by 0. Okay, so in a similar way to what we did with our extendable platforms, let's add in a var current value, which will start off as 1 for testing purposes. And we'll add in a function called display value. And all we need to do here is for item in range between 1 and the current value plus 1, keeping in mind that range is inclusive on the left, exclusive on the right, meaning if our current value is actually 0, it'll be between 1 and 1, which will return or not run effectively. So what we now need to do is we now need to procedurally generate a sprite 2D that we can have as a child. So we can do that by saying a sprite equals sprite2d.new. This creates a brand new sprite 2D node that just exists in the ether at the moment. In order to actually use this, we need to call the addChild method and add in sprite. And that will add it to the flag display node itself. What we also need to do though is set its texture to be the value that we need. And we also need to set its position to be equal to item times by the texture offset. We need to reduce the item value by 1. If we have one item, we actually want it to be at the 0 position. So that will continue that vein. So if I run display value here on ready, and then press F5, what we should see is that something has gone slightly wrong. What I didn't do, of course, is set the actual texture. So let's go to load, assets, Kenny, tiles, and let's go for a grey. Running that, I should now expect to see that we have our flag value up the top up here, which isn't quite what we want, because instead we want our flag display to be running down here. So let's just move this and get times 13. Helps if I do it in the right thing. Press F5, we now have our flag displayed, but it's off center. So there are two ways we can fix this. One, we can, inside our flag display node, we can literally just say sprite.centered equals true. But actually what I prefer to do in this situation is just offset the position of this node to account for that. So if I instead set my position to be +8 and +8, we now get the same visual result, but we're not tying in our textures to always be centered. As a little test, if I change my current value to be 2, I expect I would now get 2 flags. Now that we can actually show a value, it's time to add in the ability to actually change this value. So this is fairly straightforward. Let's add in a increment value method, and we can provide that with a value which is an integer. All this needs to do is set current value to plus equal value, and for good measure let's add in a decrement value. We can do the same, current value minus equal value. What we can do is we can call display value whenever the value changes, increment or decrement, and then we can change this back to, so let's leave that as it is. What we would potentially be useful is to have the ability to set a default value. So currently we're setting it to 2, but pragmatically we may want to allow the user to pick what this is. Let's add an export var initial value, and let's for now set that to 2. We can then in our onReady set current value equals initial value, and we'll then be able to see exactly what we had already. But we now have the ability to, from a script, change the input values that affect what this number is, which is important because we need to increment them as we collect flags. Let's make the code change so that we can actually pick up flags. So here inside the level script on the onFlagPickedUp method, which is connected to the pickup signal on each of our flags, we can link into our flag display. So flag display dot increment value. In this case, we only want to increment it by 1. If I try and make my level slightly easier, I go to line 11 and I add to my y value 16 times 5. I should now be able to get to these a bit easier. Actually, let's make it even easier. Let's do it to 16. That's the center. So now I can see that I have 5 flags. If I enter into another one, I get an additional one, etc. We can see we have a slight issue, and that's that the flags themselves don't disappear. So let's fix that. Inside our flag scene, we have our pickedup.emit method, which is on part of the onArea2D entered. Simplest way of getting the flag to remove itself once it's complete is to just call Q3 after we picked up the item. If we now run F5, we now see that those objects disappear once they're picked up. Nice and simple. Let's use this opportunity to simulate our win event. So if we enter into our image display node, let's add in a value changed signal. So here, signal value changed, and it will take a value which is an integer. Whenever our value changes, so increment or decrement, let's call this so value change.emit with our current value. We can do that in both increment and decrement. Now in our level, what we can do is we can go to our flag display, connect value changed, connect. In our level, on flag display value changed. This means that we can get a nice view of whenever a flag is picked up in one place. This is important because we might at some point do this in a different way. For example, so here we want to see if value is greater than or equal to 5, because we know we've got 5 flags. Then we want to print you win. Give that a go. We can see that it's giving us the value for everyone we pick up, and that's because our initial flag count was starting above 0. So let's fix that. So initial value is now 0. Press F5. We should now be able to pick up all apart from the last one and not receive the message. And on the last one, we should receive you win.
That's it for this video. Remember to subscribe to be notified when part 7 comes out.